All right, I'm going to quickly do a video key for my online organic chemistry in the fall of nope, this isn't fall, in the spring of 2025. I changed the format of this one a little bit. I made it to where it's no lockdown browser just because I think I got some negative feedback, or like I took a survey and students were like, oh, this thing isn't really helping me. So I thought this might help. So I'd love to hear what you think about this style of quiz, but I made it a little bit longer and you didn't have to use lockdown browser, just and tried to encourage students to use their brains and not Google anything. So, and I made each one of these questions. They're not from test banks. I made each one up. So the following molecule assign Kahn, Ingold, pre-log, which is the system used for RNS configuration, to each of the substituent chains. To tell them apart, I've highlighted each one in a different color. And I put the words that go with each color because, like the names of them, because some people have color blindness. So just in case, I wanted to make sure everyone could know what the color was. So the first thing I do, I identify my chiral center, and then I look at everything attached. So we have a carbon here, a carbon here, a carbon here, and a hydrogen. So that tells me that this green, immediately, a hydrogen is a lower molecular weight than anything else, and that's what we go on, and Kahn, Ingold, pre-log is the molecular weight of the things that are directly attached, and the only one that's different is that hydrogen, so it's 4. And then the next thing I look at is what is attached to each point of attachment. So if everything, like all 3 of these molecules are carbon, then we can't go based on just the weight of the carbon, but we can look at what's directly attached to that carbon. So this carbon, CH3, has 3 hydrogens. This carbon has 2 carbons and an implied hydrogen right here. And this carbon has 2 hydrogens and a 3rd carbon. So when I'm comparing all these, this is the first point that they're different. So initially all of them are carbon, then we look at the first point of difference. And between purple and orange, purple only has hydrogens, and comparing purple and blue, purple only has hydrogens. So purple must be the next lowest priority. And now I'm just comparing blue and orange. So between blue and orange, blue has, they both have a carbon, so those cancel each other out. These carbons are the same. And now if you compare the next one, we have 1 carbon and 1 hydrogen. So the carbon wins and is going to be the highest priority, and then this blue is going to be priority 2. So once I have my highest priorities, so step 1 is identify the priorities. To actually assign RNS, which I guess this question didn't ask you for, it just initially asked you to tell, which one is which priority. So green would have been 4, and then purple would have been 3, and then orange would have been 1, and then blue would have been 2. And this is a little tricky because you're not supposed to look at the whole entire chain to see which one's the heaviest. You're just looking at the first point of attachment. So even though this whole chain would have had a higher molecular weight than the orange one, because it is the first point of difference and not the overall weight, the blue one is a little bit lower priority. Okay, so then the next thing is I wanted you to assign RNS configuration of that molecule. So step 1 is identify priorities. Step 2 is point the lowest priority away from you, which you already have that done here. So this hydrogen is pointed away from you, so great, lowest priority is pointed away. And then 3, connect 1, 2, and 3 in order. And then determine if it's R or S configuration. R goes clockwise. S goes counterclockwise. So we have 1, 2, and then 3. I can connect them like this. So this is going counterclockwise. I also think of is the arrow at the top pointing to the left or the right? So this one is going to the left, like it's going away from where the clock would be going. So this is S, this is counterclockwise. So the configuration is S. Okay, this next one, you are supposed to draw an enantiomer of the molecule in question 1 and upload your file in a PDF. So I'm going to just go ahead and erase my work here so that I can sort of start from scratch and show you how I would approach this. So you have a couple options to draw an enantiomer. One is you can, one option, you can just swap out two groups. If you swap any two groups, it should change the configuration. But a second option would be to literally just draw the mirror image. So one option for me would be if I just made the, I'll just redraw it. So the first option, I'll leave the OH the same and the orange one the same, the blue and the orange one the same. And I'll just swap out to point the hydrogen forward and point the CH3 backwards. So I basically traded the positions of the green and the purple groups. And so this is one option for an enantiomer. That's one. Another option you could do is, oh, whoops, I didn't move this whole thing with it. So that's option one. I'll put that over here so you can kind of see it. Make it a little bit smaller. That's option one. The second option would be to literally draw a mirror image. So if you do a mirror image here, you have this orange one. So see how I pointed them now? It's like as if I flipped it over the mirror. So the purple would still be coming towards us, but just in the opposite direction. And the green, the hydrogen, would be pointed away from us still. But I've flipped the whole thing over. And now to prove to you that this is still the same configuration, the opposite configuration, just by flipping it, we've assigned priorities already. The lowest one is already pointed away from us. But if I connect 1, 2, and 3, now it's going clockwise. So either one of these would have been okay. You could swap any two groups, or you could just literally draw the mirror image. But always check yourself like I just did. Make sure that it is, that you've truly made the mirror image. So that's what I try to always do. I always just check RRS configuration just to double check. So my answer that I probably would have gone with is this one. So maybe I can drag it down and put it right here. So, and my request for only PDF is just because it's easier for the grader to grade if everything is in the same file. There's some file formats that are hard for some computers to read, like the Apple image. Like if you take a screenshot with Apple, it's HEIC. A lot of computers can't read that. So, okay. Name the following molecule. Be sure to include R or S configuration. So this molecule, the first thing I always do is find the parent chain. And it looks to me like this is the parent chain. I don't see anything longer than that. And it looks like the substituents here are closer to the right side. So I'm just going to take a guess and say that that's probably the right way to number it. So I will double check. This is a 6-membered ring, so I think or a 6-membered chain, so I think it's hexane. But if I were to go here, then it would stop at 4. And if I were to go 1, 2, 3, 4, it would stop at 5. So I think this is the longest chain. But I am going to number it from the right because then both my substituents are on 3. And if I numbered it from the left, both of my substituents would be on 4, and that's not good. So get rid of that. So first thing is this is hexane. And the second thing, so that's step 1. Step 2 is identify and number your substituents. And so we have 2 substituents here, 3 iodo and 3 methyl. So, and then the last thing is we combine it all in alphabetical order and check for stereochem. That's when I check for stereochem. So I would say this is, let's see, alphabetical order. So 3 iodo comes first. 3, oh wait, I didn't leave room for my stereochemistry. 3 iodo, check. 3 methyl, check. Hexane. 3-iodo-3-methylhexane. So I combined it all in alphabetical order. And now I will assign my stereochemistry. So when I look at this, these are all 3 carbons, and then this one iodine is heavier than carbon. I can't think of its molecular weight off the top of my head, but it's definitely way bigger or way heavier. So this is going to be priority 1. And then these 2 carbons have hydrogens off of them and another carbon. So H, H, and a C, H, H, and a C. This carbon only has 3 hydrogens. So I'm going to say it is the lowest. So that's priority 4. So I've got 1 and 4. And then now comparing these 2, then we keep going down the chain until the first point of difference. These are the same exact CH2 attached to another C. So here we have CH2 attached to another C as well, but here this carbon only has 3 hydrogens. So this is the next lowest, and then this would be 2. So that's the first thing that we do for assigning RNS configuration. Then we make sure that the lowest priority is pointed backwards, which is already happening, and now we just connect 1, 2, and 3 in order, and so this would be S. S3-iodo 3-methylhexane. So this is 5 points. Basically, I gave a point for the parent chain, for each substituent, and the proper numbering for each substituent. So like, did you get the 3 for it? And then 1 point for the RNS configuration. I guess sometimes I want you to make sure that you kind of are processing, like, okay, how are you getting points? So like any little thing you do will get you points as long as you're doing it right. For example, on this one with 4 points, I'm not just saying like right or wrong, RS, you get 4 points. It's like, do you have each substituent present and then in the right order? So half a point for each substituent, and then half a point for if they're in the right positions. Or like this next one, 6 points, that's for each substituent being in the right place. So if you've just swapped 2, you should still get 4 points. Okay, so draw the mirror image, enantiomer, of the molecule below. So this one I think is pretty straightforward. I would just do it like this. I don't know why I swapped chlorine. And alcohol and hydrogen. That's one way you can do it. Another thing, again, is you can swap 2 groups. We'd have to swap 2 groups on both of them. So if you instead had hydrogen, OH, chlorine here and hydrogen here, OH here, and chlorine there, that should also be an enantiomer. Next, write the IUPAC name for this molecule. Be sure to include absolute configuration. So again, we are naming this. I see 2 carbons, so that's step 1, find the parent chain. That should be ethane because it's 2 carbons. And then find your substituents, 1, 2, 3, 4. So they both have an alcohol and they both have a chlorine. So it doesn't matter which way we number them because you're always going to have both of them on one. So we could just say 1 chloro, and you just say 1 all shorthand, and then 2 chloro and 2 all. So I would go ahead and combine these and know that this is going to be a diol and this is a suffix. And then I would combine these and know they're going to be dichloro. And this is a prefix. So when I combine, this is step 2. Step 3 is combining them all in alphabetical order, and then is when I check for stereochemistry. So I would say this is 1, 2 dichloro ethane 1, 2 diol. And the reason I dropped the E there is because if you just have 1 alcohol, it's ethanol. So the only thing that changes would be ethanediol. So that's why I did that naming there. Okay, and then the last thing I'll do is determine what the RNS configuration is. So alcohol is the highest priority. Then chlorine is going to weigh the next. And then down here we have a carbon, so this would be 3. So typically for this kind, I don't point the hydrogen straight back. What I do for Fisher projections is I know this hydrogen's pointing towards me, And if the hydrogen is pointing towards me, you know that the configuration you get is exactly the opposite of what you want. So when I connect these 1, 2, 3, this is going clockwise. So this is going R, but that's the exact opposite configuration I want. So it's actually S. So that's one way you can do it. That's how I do it. And I'm going to erase my work and show you another way you can do it is you can flip the two priorities, but again, know that this is the opposite of what you actually want. So it would be 1. Oh, wait, did I say that alcohol was highest priority? Alcohol, that's not true. I'm sorry, I did that wrong. Erase all this, ignore all this. Alcohol weighs less than chlorine. I don't know what I was thinking. So chlorine is 1, alcohol is 2, and this carbon chain is 3. This carbon chain right here. So this goes S. This is exactly the opposite I want, so it's R. Is that what I said? No, I'm not sure what I said. Yeah, okay, this is right, though. Another thing that you can do, though, is trade positions. So if you wanted to flip this, flip 2 positions, you can put the hydrogen pointing straight back and the OH pointing back here. But if you do that, you have to know that you are going to, again, get the opposite. This is the opposite of our configuration that we want. So chlorine is 1, oxygen is 2, and this carbon chain is 3. So that is going to the left, so that's S. So again, it's the opposite. So what we actually want is R. So however you can consistently figure out Fisher projections, whatever works for you to get the right answer consistently, that's what I want you to do. And then the second one, again, we have chlorine being 1, alcohol being 2, carbon being 3. So that is going to the right. Hydrogen is already pointing backwards, so then we know that it's already pointing away from us, so that R is correct. So this is 1R, 2R, 1,2-dichloroethane, 1,2-diol. So hopefully that was helpful for you. Hopefully you liked this quiz more, and it was more of sort of like helping you process everything as you're learning it. I'd love to hear any feedback that you have on it. And other than that, I hope you have a good spring break and good luck studying.